In this video, we're going to talk about coterminal angles. So two angles are called coterminal if they have the same initial and terminal sides. So here I have an angle that's in standard position, right? The initial side is over here, and the vertex is at the origin. And so one of the angles, right, has been rotated in the positive direction 140 degrees. Okay, and here another angle has been rotated 220 in the negative direction, so negative 220. And what ends up happening is those two angles have the same terminal side. So it's really hard to see because they line up perfectly, right? But there's two terminal sides here, okay? One from the minus 220 angle and one from the 140 degree angle. So those two angles, 140 degrees and minus 220 degrees, are coterminal. They have the same initial sides and the same terminal sides over here, okay? And they are considered to be two different angles, right, because the rotation is different. If there's a different rotation taken to get from the initial side to the terminal side than from a different rotation, then those two angles are considered to be two different angles, all right? So one of the things that we'll need to do is to determine if two angles are coterminal or find another angle that's coterminal with a given angle, all right? And so the way that you would do that is to add and subtract from the angle, add or subtract, and enough times so that you can get the angle that's in the given range. So here they want the angle from 0 to 360. We're looking for an angle from 0 to 360 that would have the same terminal side as 700, okay, degrees. So the way that you would do that is just to start subtracting 360. Oops, that's not a good place for that. So 700 is definitely not between 0 and 360, right? So what you would do is to subtract 360 from there, and that would come out to be 340, right? When you did that. All right, and then check. Hey, is 340 in between 0 and 360? And the answer is yes, it is. Okay, so the answer that we're looking for here is 340. Now let me see if I can pull up on Desmos again, and let's take a look at that. All right, so 700 is right here. All right, so 700 is what we would get if we rotated and went all the way around and then almost twice around. Stopped right here, okay? So that's where 700 is. If I look at 340, if I go back 360, right, to 340, you're going to see that has exactly the same terminal, initial and terminal side as 700, okay? So they are coterminal. All right, it says find the angle between 0 and 360 that is coterminal with negative 40 degrees. All right, so we can see that negative 40 is on the other, it's less than 0, right? 700 was bigger than 360. So what we did was start to subtract 360, right? Remember, 360 degrees is one complete revolution around the with the terminal side, right? So negative 40, since it's less than 0, what we're going to do is start adding 360, right? And so what we would do is just start at negative 40. Add 360, and that comes out to be 320. 320 degrees. So since 320 is in between 0 and 360, we stop, and that's the answer, right? If we add 360 again to this, we'll get something bigger than 360, which is not what we want. We want an angle that's in between 0 and 360. That's coterminal. So let's take a look at that. Negative 40 degrees would be... So we would start here and rotate out to negative 40 right there. So start here, rotate out like this. That is, we would wind up with the same terminal side in the same position if we started at 0 and then rotated out 340 or 320 rather. We would get that same terminal side in exactly the same position. Okay, so those two angles, negative 40 and 320, are coterminal. All right, so that's an example using degrees. Now let's do with radians. With radians, it's a little bit more difficult because of the fact that you're going to have to deal with fractions if it's written in these in this form, which is the fractional multiple of pi. Okay, and here it actually says express your answer as a rational multiple of pi. So remember, that's a fraction times pi. All right, so we're essentially going to do exactly the same thing that we did. We are going to add and subtract, either in this case 2 pi, right? Why 2 pi? Because 2 pi is one complete revolution around the circle, right? And so we're going to add and subtract 2 pi until the fractional part right here is in between 0 and 2. Okay? Now you might have trouble, some people have trouble just telling, whether or not this fraction, the 44 over 9, is it between 0 and 2. But to do that, right, you just think about how many times does 9 go into 44, right? It goes in 4 times without going over, right? Because 9 times 4 is 36. 9 times 5 would be 45, right? So this 44 ninths, right, is somewhere in between 4 and 5, right? If you want, you can just look at that as a decimal, right? So you can see it's 4 point something, all right? So what we're going to do is start with 44 ninths, 44 pi over 9, and we are going to subtract 2 pi from that and see what we get, okay? So in order to do that, again, you're going to have to subtract 2 fractions. So in order to subtract 2 fractions, they have to have a common denominator, right? And then, so this 2 pi, it does not have a common denominator. It doesn't have any denominator at all, right? Because it's an understood 1 there, so you can make it that way. But then we have to get a common denominator, right? So you ask yourself, hey, what would I multiply this 1 by to get the 9 in this case? And it would be 9, right? So 1 times 9 is 9. So you'd have to multiply the top by 9 as well. So 2 times 9 would be 18. So you get 18 pi, okay? And then all you would need to do, right, is to subtract 44 pi minus 18 pi would be, what, 26 pi. Okay, so you have 26 pi here. So now the question is that between 0 and 2 pi? Okay, and the answer is no, right? Because 9 goes into 26, what, 2 times without going over, but a little more. So it's a little bit, it's somewhere between 2 and 3, right, when you do 26 over 9. So it's 2 point something. We need this number to be between 0 and 2, right, because that's what the problem is asking for, an angle between 0 and 2 pi. So So we're going to have to do this again. Okay. And so to do it again, right, what we would do is subtract off and do the same thing with 26 pi over 9. And we would subtract off 2 pi. Okay. And there's no need to go through these calculations again. When you turn 2 pi into get a common denominator, it's going to be 18 pi again. So it's going to be 26 pi over 9 minus 18 pi over 9. All right, and now that we have a common denominator, we just subtract the tops. 26 minus 18 is 8. So, and then keep it over the 9. So the answer on this one is 8 pi over 9. So you can see this one is definitely a little bit more difficult to deal with, but you've got to get used to dealing with these kinds of numbers in this class. This process, though, is pretty much the same as for degrees. It's just the numbers are a little bit harder to deal with. Again, you have to just get used to that. I know when I was in this class, I wasn't a huge fan of that, but it's just something that you have to do moving forward in this class and in other classes that you might have to take after this. So, all right, so the answer here is 8 pi over 9. All right, next one is minus 10 pi over 3. So we want to find an angle between 0 and 2 pi, coterminal with minus 10 pi over 3. So we're going to do that the same way that we did up here pretty much. We're going to be, in this case, adding 2 pi, right, until we get to a number that's between 0 and 2 pi. So why are we adding in this case? Well, we're adding because it's negative, right? Negative 10/3 is less than 0. So this number is 2, it's not between 0 and 2 pi. It's smaller than 0. So what we're going to have to do is add multiples of 2 pi until we get a number then between 0 and 2 pi. So again, you can always write this as a fraction, and because these are fractions, then we need a common denominator. That common denominator is going to be 3 in this case. So then we would say, okay, what would we multiply 1 by to get 3? And that's obviously 3. So we would also multiply 2 pi by 3. 2 pi times 3 is 6 pi. Right? So in this case, in this particular problem, we're going to be adding multiples of 6 pi until we get something that is in between 0 and 2 pi. All right, so now that we have a common denominator, we just add the numerators. Negative 10 pi plus 6 pi is negative 4 pi. And then we keep that over the same denominator. So unfortunately, that's not big enough, right? Negative 4 pi over 3 is still less than 0, right? It's because it's negative. So we're going to have to repeat this process again. And I'm just going to go ahead and cut to the chase and add what I know I need to add, which is 2 pi, but written in this form, right? 6 pi over 3. And then I add two fractions with common denominators by adding the tops. Negative 4 plus 6 pi is 2 pi. Oops. And keeping the same denominator. So 2 pi over 3, right, is definitely between 0 and 2 pi. And so that is our answer. Again, if you have problems checking that, right, then just check the 2/3, right? See if that's between 0 and 2 pi, and it is, right? It's 0.6. One thing to be careful of is if you're, there's actually a couple of ways to check, right? I've just been checking by looking at the fraction part and ignoring the pi. And as long as the fraction part is between 0 and 2, you're good, right, on these problems. That's what you want as the answer. But if you're calculating the pi in there, then right, 2 pi is about 6.28, right? So either include the pi on your calculations, right? If so, you're checking to see whether the answers are between 0 and 6.28. But to me, it's just easier to check the fraction part only and not check the pi, because if you notice, it just kind of tags along on these problems, right? So you can just make things slightly simpler by checking the fraction part and seeing if the fraction part is between 0 and 2, okay? If you actually check the full decimal, 2 pi over 3, right, it's going to be something else. It's going to be 2.094. That's in between 0 and 2 pi, which is okay, right? 2 pi is 6.28. So again, I just think it's easier just to check the fraction part, okay? All right, and that is it on this one.